After discussing into details the enthalpy of neutralization, I want us today to talk about enthalpy of precipitation. Precipitation refers to the reaction between two aqueous solution, that is two soluble salts, to form an insoluble salt that is known as a precipitate. The enthalpy of precipitation is the enthalpy change that occurs when 1 mole of a precipitate is formed. That is the enthalpy change that occurs when 1 mole of a precipitate is formed. And it is abbreviated as delta H PPT. That is for enthalpy of precipitation. Such reactions include sodium sulfate reacting with lead 2 nitrate, also a soluble salt. This leads to formation of sodium nitrate and lead 2 sulfate as the insoluble salt, simply known as the precipitate. To balance the equation, we have a coefficient of 2, and that can now lead to ionic equation as follows. That will give lead ions plus sulfate ion, that is from the sodium sulfate solution, leading to formation of lead 2 sulfate, that is the white precipitate. Enthalpy of precipitation, just like that of displacement, is influenced by other ions present in solution. e.g., the enthalpy of precipitation of lead 2 sulfate, that is in the equation above, is not necessarily the same as the enthalpy of precipitation that would be formed, that is the precipitate that would be produced when there is use of ammonium sulfate instead of sodium sulfate. Let's look at an experiment to help us discuss further enthalpy of precipitation. Procedure. Place 25 cubic centimeters of silver nitrate in a plastic beaker and record the temperature at half a time interval. That is half a minute interval. Add, that is at the second minute, and we are adding 25 cubic centimeters of sodium chloride solution. Note that temperature as T2, and for the first one T1. Record the temperature of the mixture as T4. That is the final temperature. Experimental results. The temperature change was recorded (3.5°C). That is simply T4 minus T3, where T3 is an average between T1 and T2. We want to use this temperature and molarity of sodium chloride as 0.5 molar and that of silver nitrate as 0.5 molar. Let's use this result obtained to calculate enthalpy of precipitation of silver chloride. Precipitation of silver chloride, that is a precipitate. Delta H is equals to MC delta T, that is M for 25 plus 25, adding the two volume, giving 50 cubic centimeters. Therefore, mass of the solution, that is also taken as mass of water, is equals to 50 grams. This implies that delta H is equals to 0.05 kilogram times 4.2 kilojoule per kilogram per Kelvin times 3.5 Kelvin. That will cancel that cancels that. If you multiply that, we obtain the delta H, that is 0.05 times 4.2 times 3.5, giving a value that is 0.05 times 4.2 times 3.5, and that is 0.735 kilojoule. Let's go ahead and calculate molar enthalpy of precipitation. Now, for molar enthalpy of precipitation, we must first calculate the moles of the two solutions. Thereafter, we'll go ahead and determine the molar enthalpy of precipitation. Let us start by calculating moles of sodium chloride, that is 0.5 as the molarity, multiplied by 25 over 1000, and that gives 0.0125 mole. Moles of silver nitrate is equals to 0.5 as the molarity, multiplied by 25 all over 1000, also giving 0.0125 mole. Now the mole ratio of silver nitrate reacting with sodium chloride to form silver chloride, that is the precipitate, plus sodium nitrate. Mole ratio is 1 to 1 to 1, meaning the moles of the precipitate formed is 0.0125 mole. Now let's go ahead and calculate the molar enthalpy of precipitation. Now that implies that if 0.0125 mole is able to produce 0.735 kilojoule, what of 1 mole? That will be 1 times 0.735 divided by 0.0125, and that gives, that is times 1 divided by 0.0125, giving 58.8 kilojoule per mole. So that is the molar heat of precipitation. Since energy is released during the process, the enthalpy of precipitation of silver chloride is therefore molar enthalpy of precipitation is negative 58.8 kilojoule per mole. Let us look at the thermochemical equation. That will be silver ions reacting with chloride ions, that forms silver chloride as the precipitate. Illustration of the same in the energy level diagram will be, that is y-axis, x-axis, so we have the reactants, then energy is released, that is products. So silver ion, that is just a plus, plus the chloride ion. Then there is activation energy, delta H is equals to negative 58.8 kilojoule per mole. Then the product formed is silver chloride, which is a precipitate. We can also have some other experimental data that we can use to calculate molar heat of precipitation. Let us have one other example in lieu with the same to really understand how to calculate molar heat of precipitation. So experimental results that we want to use will be as follows. T1 over 50 cubic centimeters of 1 molar silver nitrate is equals to 23 degrees Celsius. T2 of another solution, that is 50 cubic centimeters of 1 molar sodium hydroxide is equals to 25 degrees Celsius. We want to use this data to first calculate molar heat of precipitation. Given that our T4, which is the final temperature, is equals to 28 degrees Celsius as the temperature of the mixture. Now, let us first obtain delta T, that is T4 minus T3, and T3 is T1 plus T2 over 2. That is the respective temperature values of the two soluble salts. So that is 23 plus 25 all over 2, giving 24 degrees Celsius. So delta T first will be T4, which is 28, minus 24, giving a change of 4 degrees Celsius. Delta H is equals to MC delta T, and M is simply the summation of the two volumes, that is giving 100 cubic centimeters. Then that 100 times 1 gram per cubic centimeters, giving 100 grams. Therefore, delta H is equals to 0.1, that is in kilogram, by 4.2 kilojoule per kilogram per Kelvin. Then the change in temperature is 4 Kelvin. That cancels that cancels that, and that will give us a delta H value of 1.68 kilojoule. Let us then calculate the moles of the solution. The first one, we start by calculating moles of silver nitrate. That is molarity of 1 multiplied by the volume over 1000. That gives 0.05 moles. Moles of sodium chloride is the same as 1.50, 1 times 50 over 1000, and that again gives 0.05 moles, meaning they have equal moles. The mole ratio in this ionic equation is 1 to 1 to 1. Therefore, moles of silver chloride is equals to 0.05 mole. So if the 0.05 mole is able to give 1.68 kilojoule, what of 1 mole of that precipitate will require 1 times 1.68 all over 0.05, and that gives 33.6 kilojoule per mole. Since there is an exothermic reaction, energy released, the value is negative. So that is the molar heat of precipitation in this given experiment. Let us then write the thermochemical equation, the part B of the equation, writing thermochemical equation, that is simply silver ion reacting with the chloride ion to form silver chloride in solid. Then delta H is negative 33.6 kilojoule per mole. Part C is the illustration in the energy level diagram. We want to have the energy level diagram. That is the y-axis, x-axis, reaction path, enthalpy, so we have the reactants at higher energy, then products at lower energy, meaning it is released, that is activation energy. Then delta H is negative 33.6 kilojoule per mole. Then the reactants, we have silver ion reacting with the chloride ion, and that gives a product of silver chloride. So that is the energy level diagram for that given. In this other one, we also have the same, that is reaction path, and energy. Simply enthalpy. That is all about molar heat of neutralization and precipitation. Specifically in this lesson, we have looked at the molar heat of precipitation, where in the two examples we have studied a case whereby there is formation of silver chloride precipitate from silver nitrate and sodium chloride as the soluble salts.